Hello, I am Myron Giannakis, and this is my presentation of an article I chose from the Quantum Machine Intelligence Journal of Springer for the course of quantum computing. The article is entitled If AI Machine Cannot Think, Can QI Machine Think? From Negative Numbers to Quantum Intelligence for Mind, Light, Matter Unity. The author presents an extension to the Turing question, Can Machine Think? A deeper and probably more realistic question: if AI machine cannot think, can QI machine think? And he begins by proposing QI, quantum intelligence, as an equilibrium-based logical unification of artificial intelligence, AI, and biological intelligence, BI. QI is based on logically definable causality, which can resolve the mysteries in quantum mechanics, and as an equilibrium-based natural intelligence underpinning to AI and BI, it is philosophically, logically, and fundamentally different from quantum AI, which is used just to extend artificial intelligence. This article is mostly theoretical and philosophical, while the author Wenran Zhang conveys an approach oriented to the Eastern philosophy as opposed to the European that was commonly used. And it is a deeply interesting paper that approaches the initial question in new ways, suggesting bipolar models of logic instead of Boolean to more effectively express the yin-yang theory of the universe. So instead of a 0 to 1 scale, the author prefers a -1 to +1, and like that he starts a research on the negative numbers divided in three main puzzles: the East-West puzzle, the Past-Future puzzle, and the causality puzzle. After this analysis, he goes on to conclude about the thinking machine puzzle and how could quantum computing become analytical to reach mind-light-matter unity and make AI and QI machine think. So to unite mind and body through um, light, the logicality and the geometry of light. The first puzzle he presents is the famous question of Joseph Needham: why didn't China have a scientific revolution? When China have a scientific revolution, considering its early scientific accomplishments? Um, Considering its early scientific accomplishments, which he rephrases as why did Europe become the cradle of modern science after Renaissance and not China? He states that the reason was not having a formal logic and geometry for equilibrium and harmony, even though China was the first to accept negative numbers as a bipolar logic. Then, in the past-future question, the author compares and relates the older Eastern philosophy to the modern quantum mechanics, beginning from the yin-yang to the negative and positive Cartesian coordinates that led to the imaginary numbers and the real imaginary Hilbert space, and finally to the particle-wave duality, where particle and wave are just a pair in this a real imaginary Hilbert space, and he connected all this for the complementarity of quantum mechanics through the philosophical and logical bipolarity. The third puzzle was the one of causality, where the author pointed out the debate between Einstein and Bohr and the fact that Einstein asserted that physics constitutes a logical system of thought, and without causality for quantum non-locality, he refused to accept quantum mechanics as a complete theory. Some say that after the 2022 Nobel Prize for experiments with entangled photons and establishing the violation of Bell inequalities, Bohr's quantum mechanics won and Einstein's realism lost, but that's not true since the causality principle is the cornerstone of science. Quoting the author, without cause-effect, science would be religion. Next, he presents some theoretical and technical limitations of quantum mechanics, such as the geometrical limitation, saying that Hilbert space is a background-dependent space-time geometry, and without background independence, quantum entanglement is logically unreachable. Another is the complementarity limitation, where particle-wave complementarity principle asserts that opposites are complementary, but particle and wave are real imaginary pairs on the in Hilbert space, where strict bipolar interactive opposites are omitted. The causality limitation, he points out that where he points out that a causal description of a quantum process cannot be attained. And he provides also other limitations such as uh, the representational limitation, logical limitation of quantum mechanics. And he finally concludes the article, the paper, quoting an MIT professor, Seth Lloyd, as the universe itself is a quantum computer. Once we understand the laws of physics completely, we will be able to use small-scale quantum computing to understand the universe completely. And human mind, as part of the universe, must be a quantum intelligence machine for quantum cognition. So, returning to the initial question, if AI machine cannot think, can QI machine think? The author suggests that the key to the answer is the mind-light matter unity QI theory. Thank you.